this is what we had discussed in the morning session. This was the last slide I had discussed. To represent real constant in exponential form, a scientific form, and the range of values which you can represent in exponential form is minus 3.4e38 to plus 3.4e38. Two examples I have given here. Plus 3.2e minus 5. You can observe mantissa part is in decimal notation. Exponent e is given, and the exponent is an integer constant which is negative. In the second example, you can observe 4.1e8, where we have not specified the sign for neither the mantissa nor the exponent. By default, they are treated as positive. So similarly, the third example you can see minus 0.2e plus 3. So e means it is into 10 raised to that exponent whatever you have specified. The last example you can see minus 3.2e minus 5, where we have given negative value for mantissa. So these are two examples of real constant represented in exponential notation. So what you have to remember is we will go for exponential notation, a scientific notation, if you want to represent two large value or two small values. So this is the application of exponential notation. Moving on to the next type of constant, that is character constant. So just recall the classification of C constants. We can classify broadly into numeric constant and character constant. We completed numeric constants, which are in turn classified into integer constants and real constants. Now what we are discussing is character constants. So how character constants can be in turn classified? Single character constant and that is string constant. Okay. First we'll see single character constant. So any character, you know the character set of C. Already we have discussed character set of C. So anything that is represented within a pair of single quotes, one character, okay, represented within pair of single quotes, that is called as a single character constant. A single character enclosed within pair of single quotes, it is called as single character constant. Okay. So that character, it may be letter, it may be digit, it may be special symbol or blank spaces. So that we have already discussed in character set of C. So how character set is classified? Maybe letter, uppercase or lowercase letter, it may be digit 0 through 9 or special symbol or white spaces or blank space you can consider. So any single character enclosed within pair of single quote, that is called as single character constant. Okay, few examples you can see here. See, capital A represented within pair of single quote, lowercase a, digit 2 represented within single quote, blank space, single blank space represented within pair of single quote. So all these are examples for single character constant. So what you have to remember with respect to single character constant is, so each character, whatever supported in ANSI C, so the entire character set, it is associated with an integer value. What do you call that integer value associated with each and every character supported? It is called as ASCII value. So what ASCII stands for? It is American Standard Code for Information Interchange. So this is what the abbreviation for ASCII. So remember, the character constant, it is associated with an integer value. That integer value is called as ASCII. So if you want to know what is the ASCII value associated with a character, what you can do is you just have a printf statement. Any particular character in the character set, if you want to know its ASCII value, just write a printf statement. Now you know the format specifier to be used. So to print the ASCII value. So what I told, ASCII value is nothing but an integer value. You know what is the format specifier you are going to use to print an integer value? It is %d, right? So just use the format specifier %d and represent that character whose ASCII value you want to know. So that character you represent within pair of single quote. So for that, the ASCII value gets printed onto the screen. So this is how you can find out the ASCII value associated with any character. So remember, in general, each character is associated with an integer value. What do you call that integer value as? It is ASCII. So this is the standard code that is used for representing characters. So whatever the character you are having on the keyboard, for each of the character, there will be an ASCII value associated. Okay, that is an integer value. Say for example, at least these character range you can remember. Capital A to Z. Capital letter A to Z, the ASCII range is 65 to 90. Capital A, it is 65, the ASCII value. For B, it is 66. C 67 and so on. For capital Z, it is 90. For lowercase a to z, it is 97 to 122, the ASCII range. For digits 0 through 9. For digits, here we are taking it as character constant since they are represented within pair of single quote. The ASCII range is 48 to 57. That means what is the ASCII value for 0? It is 48. For character 9, it is not integer 9 we are discussing. It is character 9. What is the ASCII value? It is 57. So 48 to 57 is the ASCII range for 0. So at least these ranges you can easily remember. Capital A to Z, 65 to 90. Lowercase a to z, 97 to 122. Character 0 to 9, it is 48 to 57. So as I told, if you want to know ASCII value of any character, you can just have a printf statement. So just see here, let me just have some printf statements. Printf, I'll give percentage %d. Since ASCII value is a integer value, we'll use the format specifier percentage %d, comma, and close the double quote. So I want to know the ASCII value of capital A. I'll represent capital A in single quote. And now I'll just try to execute it. See what will be the output you are going to get. Observe, for capital A, what is the ASCII value? It is 65. So what is the format specifier you are going to use to print a character onto the screen? What format specifier you have to use to print the character onto the screen? We have discussed different format specifiers. Can anyone tell the format specifier percentage? Come again.
C.
Yes,
Percentage
very
C.
good. Yes, percentage C. So if you want to print the character onto the screen, make use of the format specifier. Yes, percentage C. If you want to print its ASCII value associated with that character, make use of the format specifier percentage D. See, I want to print the output in this format. I want to print the character, okay, and also its ASCII value. So let me just print like this with these arguments in the variable list. Character A represented within single quote, comma A. So since two format specifiers I have given, I need to have two variables or two arguments in the variable list. Just observe, since the first format specifier given is percentage %C, character A gets printed onto the screen. Okay, constant I have given in the variable list here. After colon is printed, we have used the format specifier percentage %d. What it prints is the ASCII value associated with that character. So just observe what will be the output now. See, depending on what format specifier you have used, accordingly the data gets printed. So for the first format specifier, it is printing character A. For the second format specifier, you can observe it has printed the ASCII value associated with that character. So any characters ASCII value you want to know, this is how you can print it. Or if you know the ASCII value, if you want to know what is the character that ASCII value is representing, vice versa operation is also possible. So for example, I'll write printf percentage %c, comma, let me give say 122. I want to know what is the character associated with this ASCII value. I have given the format specifier percentage %c. You know, ASCII is an integer value, okay, which is associated with each character supported in C. So just see what will be the output. Observe, it is lowercase z. You know, ASCII value of lowercase z is 122. What I have done? I have used the integer value 122 in the variable list, and I have used the format specifier as first argument in the printer, that is percentage %c. What it has done? It has printed the character associated with the ASCII value 122. Like this, vice versa operations are possible. Given with the character constant, if you want to know the ASCII value, you can use the format specifier percentage %d. Or if you are knowing the ASCII value, if you want to print the character associated with that ASCII value, you can print it. Are you getting? So if I want to know the ASCII value of space, I'll just give within single quote, I'll give blank space. I'll use the format specifier percentage %d. And one more characters, ASCII value I want to know. Say new line character. You know how to represent new line character? \n is also a single character constant. Both \n and n together, it is called as a single character constant. Just observe what are the two character constants I have given in the variable list here in the printer. So one is first is the blank space I've given within pair of single quote. Then I've given \n within pair of single quote. The format specifiers I've used is %d. Since I want to know the ASCII value associated with these character constants. So if I print the value, what you'll get is, just observe, see, 32 and 10. So 32 is actually the ASCII value of blank space. Single character space, ASCII value is 32. And for new line character, what is the ASCII value? It is 10. So any character, if you want to know the ASCII value of ampersand, or if you want to know the ASCII value of modulus operator, what you are having. So any symbol or any single character's ASCII value, if you want to know, just represent that character constant within pair of single quote. So what you can do, and the format specifier you can use is %d to know the ASCII value. If you want to print that character, make use of the format specifier %c. Okay. So if I write the statement like this, if I write printf %c close double quote, comma, okay. So let me write a hello. Let me write this. I'll write here hello %c. Hello %c. Hello I've given, and I've used \n here, the single character constant. Can anyone guess what will be the output? If I execute this program, what will be the output? What is the execution effect?
Hello 10, hello.
Have I used %d format specifier? Just observe what format specifier I have used.
No, ma'am, no.
What will be the output? What is the execution effect of new line character? First, printf how it works. The double quote, opening double quote indicates start of the string. It keeps on printing sequence of characters. HELLO gets printed. So then %c is encountered. Some character is to be printed. So it picks that character from the argument list. So where /n is given. Instead of directly writing \n within the pair of double quote, what we have done here is we have used the format specifier %c. That character we have given in the variable list here. Okay, both are same. Directly giving hello \n hello. If this is given, you know what is the execution effect, right? If I give this directly, you can guess what is the output. Hello will be printed, cursor will be brought to the new line in the output screen. Then again, hello will be printed in new line. So two words hello printed in two lines. Yes or no? So same effect, if I want, what I can do is I can give hello %c hello, then I can put a comma, and then I can use that is \n. Within pair of single quote I'll use. Just see what is the output. Observe. Are you able to analyze this? What output you have got? HELLO is printed,
Yes.
%c. It picks the character constant here. That is, the cursor is brought to the new line. You know the execution effect of new line character. It brings the cursor to the beginning of new line. Then next set of characters are printed. Once closing double quote is encountered, it indicates end of the string. So this is what the output you are getting. If I had used %d, as you told, you would have got 10. If I use %d here, okay, hello %d hello, it prints the ASCII value of new line character, and then it prints hello. What is the output of this? Correct? So if it were to be %d format specifier, what you told is correct. HELLO is printed, %d format specifier is used. That means some integer value is going to be printed. It picks the character from the list, which is new line character. What is the ASCII value associated with new line character? It is 10. 10 gets printed in that position. Followed by that, you are having HELLO, again these sequence of characters that gets printed onto the screen. Are you getting? Got the difference between %c format specifier and %d? C prints the character, D prints the integer value associated with that character. So character and integer you can use vice versa like this. Hope this is clear. Hope you have understood single character constant.
Yes, ma'am.
Okay, shall I proceed? Fine. So this is about single character constant, and if you want to perform any arithmetic operations on single character constant, that is also possible. So since it is character is associated with an integer value, if I want to add some integer constant to a character constant, that is fine. If I want to subtract or if I want to add any manipulation I want to do to that character constant, that is possible. So just observe in this example, I have declared a variable ch of character data type and I have initialized it with character a. Then what is the operation we are performing? Ch is equal to ch plus 2. Let me just type it in the code blocks here and we shall see what will be the execution effect. So what I have done in that example is I have taken a variable ch of character data type and I have initialized this character variable with character constant a. So now I am trying to perform some arithmetic operation on this character variable. Say ch is equal to ch plus 2. Okay, this is the operation we are performing. Now we shall try to print the character and the ASCII value associated with that character variable. So let me just printf percentage %c, okay, equals percentage %d. This is the format in which I'm printing the output. I'll close the double quote. Then I'll write the arguments as ch comma ch. See what is ch? It is a variable. What type of variable is ch? It is a character variable. Okay, just observe two format specifiers I have given in printf, percentage %c and percentage %d. So in the from the argument list, it takes ch. So ch is a character variable. Whatever the data stored in ch, its associated character gets printed using the format specifier percentage %c, and its associated ASCII value will be printed with the format specifier percentage %d. Before to that, just see what arithmetic operation we have performed. So this is possible since character is associated with an integer value. Arithmetic operations we can perform on character constant or it may be a variable. See, what is the ASCII value of capital A? Internally it performs ASCII operations. Getting? So capital A is associated with ASCII value 65. So 65 plus 2. What is the value? It is 67. So 67 is the ASCII value stored in CH. So now can anyone tell what is the character that gets printed using printf? What character that gets printed? 67 is the ASCII value of which character?
67
Capital
is
A.
CH.
C.
Plus
C, right?
C.
C. So it prints C is equal to 67. So C, since C is the ASCII value, sorry, for 67, the character is C. Its ASCII value is 67. So it prints the character and its ASCII value. Just observe what is the output you are getting for this printer. I've done some arithmetic operation. What arithmetic operation we have performed? It is addition operation. We are adding 2 to this character variable. So CH initially holds character A, whose ASCII value is 65. 65 plus 2, we are getting 67. So that ASCII value is stored in the CH variable. And now using different format specifiers, we are printing character as well as the ASCII value. So the final output will be C is equal to 67. Okay. So if I had initialized it to say F, capital F, if I perform CH minus 2, so what will be the output? Just see, I perform subtraction operation and observe what is the output. Capital D gets printed, that is ASCII value, that is 70 minus 2 means it is 68, which is the ASCII value of capital D. ASCII value of capital F is 70. You are subtracting 2 from it, you will get 68. The character associated with this ASCII value 68 is capital D. So this is how we can just perform arithmetic operations on character. So internally it takes the ASCII value associated with that character and it does the manipulation. Clear? This is about single character constant. Hope this is clear. Coming to the next type of constant, it is string constant. So what do you mean by string constant? So it may be a single character you are enclosing or you are representing or sequence of characters. Anything enclosed within pair of double quotes, that is called as a string constant. So it may be special symbols you are enclosing or it may be alphabets, digits. So it may be any sequence of symbols. So enclosed within pair of double quote, that is called as a string constant. So I have seen in printf how to print a string. So we'll use pair of double quotes to print a string. So that within double quote, I can specify any character. It may be alphabets, digits, special symbols. So the entire character set you can consider. So anything you want to represent as a string constant, just enclose that string constant within pair of double quote. So this is what you need to know about string constant. Okay. So string constant, it is sequence of characters enclosed within pair of double quote. Whether it is a single character you are representing or sequence of characters, if you use pair of double quotes, then that is treated as a string constant by the compiler. You got the difference between single character constant and a string constant? So if I just represent in this example, you can see in these examples, ABC I have represented within pair of double quote. 1, 2, 3 is represented. Each is a string constant. Third example, you can see I have taken a single character A enclosed within pair of double quote. So this is not treated as a character constant, single character constant. It is a string constant. It may be one character you represent or sequence of characters. Anything you represent within pair of double quote, then that constant is treated as a string constant. So how a string constant is stored in memory, that we'll be discussing once we go to arrays concept. So string is nothing but sequence of characters. So if you want to make a variable hold a string, so you need to go for arrays concept. That we'll be discussing in later units. Okay, for the time being, just know that to represent string constant, we'll use pair of double quote. It may be one character or sequence of characters as you are seeing in these examples. See, 2 plus 3 I have represented within pair of double quote. So this is a string constant. So if you are storing this constant in a variable, so in that case, so how actually that constant gets stored in the memory? For each character, ASCII value will be stored in the memory, and to indicate end of the string, there will be a special character constant that is stored, that is called as the terminating character, which is null character. So just remember this. At this point, just I'll give this note. For each string, okay, any sequence of characters, if you store this in the memory, how it will be stored in the memory is, okay, each character's ASCII value will be stored. Say for example, let me consider this example constant, which is a string constant. Character 2's ASCII value gets stored in the memory, and you know character, it will be occupying only 1 byte of memory space. Okay, then ASCII value of plus will be stored in the next byte of memory location. ASCII value of 3 will be stored in the next byte of memory location. And to indicate end of the string, a special character, that is null character, \0, this is called as the null character, which is always a terminating character for a string, that gets stored in the next location to indicate end of the string. Okay, if it were to be single character constant, say 2, if I write it like this, single character constant, if it is stored in the memory, it occupies only 1 byte of memory space. Okay, in that 1 byte, what gets stored is ASCII value of this character constant. So what is the ASCII value of 2? That gets stored. 48 is the ASCII value of 0, 49 it is 1, 50 is the ASCII value of 2. So 50 gets stored in that 1 byte of memory location. So this is how a character constant will be stored in the memory. Okay, any character constant you take, its ASCII value gets stored in the memory. Whereas if you are taking a string constant in the memory, if you are making a variable hold a string, then how that string constant will be stored in the memory is, each character's ASCII value will be stored in sequence. At the end, there will be a terminating character that is stored to indicate end of the string, that is called as null character. So just remember, null character, it is the terminating character for the string. So how do you represent a null character? It is \0. So this is one of the character constants supported in C, that is null character, which indicates end of the string. So whenever you are reading sequence of characters during execution time to store it in a variable, to indicate end of the string, compiler automatically appends null character at the end of the string in the memory. So that's you can go just whenever you are going for processing the string, you can keep on accessing the character stored in the string until you encounter a null character. Once null character is encountered, you can infer that it is we have reached end of the input. Okay, so all those how actually we are doing the manipulations on strings, all those details we'll be discussing in later classes. For the time being, just know how to represent a single character constant and how we'll be representing a string constant. So single character constant is associated with an ASCII value, which is an integer value. To print that ASCII value, we'll use the format specifier %d. If you want to print the character associated with an ASCII value, use %c. If you want to print ASCII value, use %t. So string constants, how it will be stored in the memory. So directly if you write string constant within print, that is as argument in the printf, you will not get any ASCII values. So you need to store the string constant in a variable, and if you try to access what is stored in the memory, what you'll get is each character in the string, its ASCII value will be stored. At the end, null character will be stored. So this is the memory map for a string constant, which is stored in a string variable. So how to declare a string variable and how to make a string variable hold a string constant, all those details we'll be discussing once we go to the almost last but one unit, that is fourth unit, when we discuss strings topic. Okay, so this is about string constant. Moving on to the last type of character constant. So this is also a single character constant. It is a special single character constant. So already we have seen two categories of character constants, single character constant and string constant. Backslash character constants, they are also called as escape sequences. These are also actually single character constants, but two characters combined together, and it is treated as a one character by the compiler. Okay, as an example, you can consider \n, where backslash and n together they are called as it is called as a single character constant, which is a new line character. So this is a special single character constant which is supported in C, backslash constant. So why it is called as backslash constant? Since it starts with the symbol backslash, it is called as a backslash character constant. And why it is called as escape sequence? Okay. So what is the reason? These backslash character constants, they are called as escape sequences. See, this backslash, if you use backslash prior to the character, say n or character o, that is integer o, a few examples I'll give with the execution effect we'll see. So if you are going to prefix backslash to the character, actually it causes an escape from normal way characters are interpreted. So that's why they are called as escape sequences. Say for example, let me just show with this implementation here. We'll see. Just observe, if I write printf, I'll try to print hello only. Hello message I'll printf hello. In between, I'll just use n. HEL, n, LO I have given. If I just print the output, what will be the output? I have used character n within pair of double quote, and I'll try to print it. Is this treated as a backslash constant? No, right? If you just see the output, what you are getting, just observe what is the output you have got. It is HELN, normal character it is treated as. So N is a normal character that gets printed onto the screen. If you want to treat this as a backslash constant, so just to change the normal execution effect, or just to escape from the normal way this character is interpreted, we are going to prefix backslash. Okay? So since backslash causes an escape from the normal way this character is interpreted by the compiler, they are also called as escape sequences. So when we go for escape sequences, usually in the output statement, that is in the printf statements, to format your output, we'll go for these escape sequences. Okay, this is the application of backslash constants. Yeah, escape sequences. We'll use them in printf to format our output. Okay, and why it is called as backslash constant? Remember, since it starts with the symbol backslash, it is called as backslash constant. Why it is called as escape sequence? Since if we are using backslash, which causes an escape from normal way that character is interpreted by the compiler, it is called as escape sequence. Just observe, if I prefix n with backslash, so once, since it is starting with backslash, compiler will interpret this as an escape sequence or backslash constant, and it tries to bring the cursor to the beginning of new line. See what is the output you are getting now? HEL is printed. Since we have encountered backslash, followed by that we are having this character n. This is treated as a single character constant, which is a backslash constant. Cursor is brought to the new line and it prints next set of characters, that is elbow. So that's why it is called as escape sequence. If I remove backslash, it is treated as normal character. If I just prefix backslash to it, it is treated as backslash constant. So just observe from how in normal way the compiler interprets the character, and if backslash is given, how that is interpreted by the compiler. So that's why these character constants are called as backslash constants. So and which are those backslash constants supported? Um, Having this list, let me just display that list. See, at least these backslash constants you need to remember. If it is asked to explain backslash constants with examples or list at least 5 backslash constants, so these backslash constants you can list. Already you are aware of new line character, that is backslash n. I also told in the previous slide about null character. The escape sequence, the symbol you are using is backslash 0. It is integer 0. It is not O. It is integer 0. And observe, in each of these characters listed in the second column in this table, it is starting with backslash. So backslash character constant starts with the symbol backslash. Backslash and n together it is called as a single character constant. As I already shown in that example, to find the ASCII value of this new line character, you know how I had represented this new line character? It is within pair of single quotes. I had used backslash n, right? See how we represent a single character constant? Backslash n represented within pair of single quote. So remember, backslash and n they are not treated as two different characters. It is treated as a single character constant in C. This is a special single character constant supported to bring the cursor to the beginning of the new line. Okay. So since it is a single character constant, you know how to represent a single character constant. It is within pair of single quote. So if I just write printf %d comma within single quotes, if I use slash n, what it prints is 10. So you need not remember the ASCII values listed in the third column. Just for your reference, I have given the table which contains the ASCII value of these backslash constants. So for new line character, it is 10. And you know the execution effect of new line character. Coming to the next escape sequence, that is horizontal tab. T stands for tab. Okay. T, it stands for tab. What is the execution effect of tab is? It leaves 8 character space. So if you want to leave one character space, you'll give a blank space within pair of double quote. If you want to leave 8 character space, that is 1 byte space, you will go for backslash T. Okay. So let me discuss in parallel each of these character constant. The execution effect we'll see with this implementations. Let me go to the second one, new line, that is tab. I'll replace n with p, HEL backslash T LO I'll give. Okay. And we shall run it. Just observe, HEL is printed, backslash T is encountered, it leaves 8 character space and then it prints LO. If you want to see it still clearly, what we shall do is, let me just print some sequence of characters, then I'll use backslash n, then I'll use backslash T and I'll print some message. Let's see what is the execution effect of this. I've used 2 escape sequences in this printer. So this is the sequence of characters I've printed. Then I've used backslash n, which brings the cursor to the beginning of the new line. After that, I've used backslash t, which leaves 8 character space. You can make a count of it. It is 8 character space. See, 3, 4, 5, 6, 7, 8. After 8 character space are left, next set of characters are being printed. If they give you this printf statement and if they ask you to guess the output, this is what the format of the output you have to print. See, H is aligned to character C. Capital H is aligned to character C in the output screen. So exactly you need to write this output. The sequence of characters HEL, SK, JD, HCS is printed. Slash n brings the cursor to the beginning of the new line. Slash t leaves 8 character space in that new line. After that, HELLO is printed. Once closing double quote is encountered, it terminates the string. Okay, this is the execution effect of slash t. How many character space slash t will leave? It is 1 byte space. 1 byte is sequence of 8 bits. So 8 character space will be left for backslash t. Okay, this is about tab space. Moving on to the next character constant, that is carriage return. So carriage return, it is backslash r. And the escape sequence or backslash constant, it is used as backslash r. So it is called as carriage return. And the ASCII value of carriage return is 13. Okay, you need not remember these ASCII values. As I told, it is just for your reference. And no one will ask in the exam to write the ASCII value of backslash r or backslash b. It is hard to remember. Okay, at least for characters A to Z, that is lowercase and uppercase, digits 0 to 9, try to remember the ASCII values. That will be helpful once we go for strings. Okay, now we shall see the execution effect of backslash r. If I use here, just observe, let me remove this and I'll use backslash r. So what happens once backslash r is executed is, it brings the cursor to the beginning of the same line. Backslash n brings the cursor to the beginning of new line, whereas backslash r brings the cursor to the beginning of the same line. Okay, this is the execution effect of backslash r. So now what will be the output? If I execute this, what will be the output? See, HELSKJDHCS gets printed. After that, the cursor is brought to the beginning of the new line. It overwrites the character from that position. So what will be the output? H gets printed in the first column, then E gets printed in the second column, L gets printed in the third column, L gets printed in the fourth column, and O gets printed in the fifth column. So what is the final output you are going to see? Can anyone guess what is the final output?
Hello JDHCS.
Yes, very good. HELLO gets printed, followed by that next set of characters in the rest columns in the output screen, that will be retained as it is. JDHCS will be printed. Just see the execution effect here. Okay. Hope you have understood the usage of carriage return. New line character brings the cursor to the beginning of the new line, that is to the first column in the new line, whereas backslash r brings the cursor to the beginning of same line. So HELSKJDHCS is printed, and since backslash r is encountered, it brings the cursor to the beginning of the same line, and HELLO is printed. So it overwrites the character at that position. So finally, if you see the output of this printer, this is what the output you are going to see. HELLOJDHCS. Okay, this is about carriage return. So we have seen 3 escape sequences: backslash n to bring the cursor to the beginning of new line, backslash t to leave 8 character space, backslash r to bring the cursor to the beginning of the same line. So what about backspace? Backslash b. What is the execution effect of backslash? You have used backslash in keyboard, right? So it, whatever the last character is there, that gets deleted. But here we don't say the character gets deleted. So it brings the cursor to one character back. So that is about backspace. Say, if I just write, let me just write one printf statement. So backslash b stands for backspace. Can anyone tell what is the execution effect of this? Let me remove this and make it simple. Okay. Now tell the execution effect of this printf statement. Backslash b brings the cursor one character back. What will be the output?
HEL hello.
Yes. So character yes will be replaced with the next set of characters, that is HELLO. So whatever the character you are finding in the fourth column in the output screen, so that will be replaced with capital H, followed by that in the next set of columns it prints ELLO. As you told, that will be the output, that is HELLO. See? HELS gets printed. Since backslash b is encountered, it brings the cursor one character back, where s is printed. In that is the cursor is brought to the fourth column in the output screen, and from fourth column it prints this sequence of characters. HELLO will be printed. So the final output what you'll see is HELLO. This will be the output. This is about \b, backspace. What about alarm? \A, it is bell alert or alarm you can say. Once this is executed, you'll hear a small beep sound. Okay, that is the usage of \A. So just you can execute and try. If you just have this \A, you can hear a small sound. I don't know whether you are able to hear. So you can give here \A. Once I execute it, a small pip sound will hear. Okay, that is about \A, alarm or bell alert. Okay, coming to the next escape sequence, that is the question mark, \question mark, and quotation mark. You are having single quote, a double quote if you want to print. You are having these escape sequences. So that is sixth one. Let me just give slideshow here so that it's clearly visible to you. Just observe here. We have discussed \n, \t, \r, \b we have discussed. \a, as I told, you'll hear a small beep sound. Quotation mark. It is double quotation mark. If you want to print, you need to use double quote. And single quotation mark if you want to print, you will use this is single quote. Question mark if you want to print, you can use question mark. And backslash itself, if you want to print, you can use double backslash. So once I give a backslash, compiler will interpret this as a backslash constant. But if I want to print backslash itself onto the screen, I can use double backslash so that one backslash gets printed onto the screen. And null character, it is a terminating character for the string. So let us discuss these last 5 escape sequences: quotation mark, single quote, question mark, double backslash, and null character. So that with example I'll show here. So just see, if I use \0, this is called as the null character, \0. What will be the output? HELS \0 HELLO. So this is what the string I have given within printf. If I execute this, what may be the output? Can anyone guess the output? What is the purpose of \0? What it indicates? Once compiler encounters \0, what it interprets that? Terminating character, right? A null character is a terminating character for the string. When I execute, what happens is HELS, these sequence of characters will be printed. Since \0 is encountered, it indicates end of the string. It won't go for processing rest of the characters. It just terminates the string. So just observe what is the output you are going to get. Only HELS is printed. Wherever you insert \0 in a string constant, only till that point it is able to print. So next set of characters will not be printed. Since \0 is encountered, it indicates end of the string. This is null character. More often we'll be using this null character when we deal with string constants. When we make a variable hold a string constant, and once we do manipulations on string variable, we'll see this that is null character. Okay. For the timing, just know \0 is called as the null character. It indicates end of the string. So if I want to print double quote, okay, I cannot give like this. Double quote, I cannot give 3 double quotes here to print double quote. So within double quote, I cannot give double quote. If I want to print, say hello, I want to print within pair of double quote. If I just print it like this, will double quote get printed? No, right? See, what is the output if I simply give within pair of double quote hello? Whatever we give within double quote gets printed. But if I want to print double quote also, then how to print it? We need to use backslash constant, that is \double quote. So before H, I want to print a double quote, opening double quote, and after O, I need to print a double quote. See, I'll use this escape sequence \double quote. What is the output? Hello will be represented within pair of double quote. Just observe the previous output what I gave and this output. Okay, let us just compare both. Write printer hello N and use here \n semicolon. We close the output screen. Yes. Just observe the output. In the first printer, within double quote, whatever we are having, that gets printed. HELLO is printed. /n is encountered. It brings the cursor to the new line. In the second printf, backslash within double quote, we have encountered a backslash. That means some character escape sequence is considered. It is backslash double quote, which prints one double quote onto the screen. Followed by that, you are having sequence of characters HELLO. And again, backslash is encountered. That means compiler will come to know that another escape sequence is encountered. It is backslash double quote, the escape sequence, which prints one more double quote, and closing double quote is encountered, which indicates end of the string. Okay. If you want to print double quote onto the screen, you can make use of the escape sequence backslash double quote. Similarly, if you want to use single quote, so I want to print H onto the screen, or say D I want to print onto the screen within pair of single quote. I can use this escape sequence. So just observe what is the output you're going to get. Let me comment the first printf. Observe what is the output you're getting. See, character D represented within pair of single quote. Backslash single quote, if you use, it prints single quote onto the screen. So two backslash constants are used in this printf. Backslash single quote before D and backslash single quote after D. It has printed two single quotes in the output. So this is about backslash single quote. So if you want to print backslash itself, then you have to use double backslash. So if I simply give backslash within printf, it will not print. So I'll give backslash D. Okay, it will not print backslash onto the screen. You'll get simply D. Just see the output, you're getting only D. So it is not, D is not a backslash character constant. So that's why it is treated as normal character and it prints D. But if I want to print backslash, I have to use double backslash. See, before D and after D, I want to print a backslash. Just see what is the output you are going to get. Let me run this. Okay, see, you can print backslash by using the escape sequence double backslash. It prints one backslash onto the screen. Okay, this is about the escape sequences or backslash constants. So since they are starting with backslash, they are called as backslash constants. So since the backslash is going to cause an escape from the normal way characters are interpreted by the compiler, they are also called as the escape sequences. And these are few backslash constants supported in C. New line character backslash n, horizontal tab backslash t, carriage return backslash r, backslash b, backspace, then bell alert backslash a for alert or alarm you can say, quotation mark, that is double quote, backslash double quote, apostrophe, backslash single quote, question mark, backslash question mark, and double backslash, it is backslash escape sequence, backslash 0, it is null character. And these are the ASCII values. 10 for new line, 9 for horizontal tab, 13 for carriage return, 8 for backspace, and so on. And as I told, no need of worrying about the ASCII values. At any point of time, if you want to know the ASCII value of any of these escape sequence, just represent it within pair of single quote. Say I want to know the ASCII value of null character. What I'll do, I just use %d. If you want to print along with the message, you can print it like this. See, ASCII value. Let me just print with this message. I want this output to be printed. ASCII value of null character is %d, comma. I'll represent it within pair of single quote. So what is the output you are going to get? It is 0. Null character ASCII value is 0. This ASCII value you can easily remember. Null ASCII value is 0. Let me just execute. See what output you have got. Sequence of characters within pair of double quote is printed. %d, the format specifier is encountered. That means compiler comes to know that some integer value is going to be printed. It picks that character constant, null character. Its associated ASCII value gets printed at this position. It is 0. Okay. So any character's ASCII value you want to know, just represent it within pair of single quote. use the format specified percentage d, it prints that character. Okay. So try to remember these ASCII values. Capital A to Z. What is the ASCII value? Can anyone recall and tell? What is the ASCII value of capital A to Z? Yes?
65 to
65 to
97.
90.
Very good. 65 to 97. This is the ASCII range. For lowercase a to z, what is the ASCII range?
97,
Yes, 97 to
120,
very good.
120.
122. Then digits 0 to 9. What is the ASCII value? 0 to 9. It is 48 to 57. This is the ASCII range. And for new line character, at least these most often we'll be using these characters. So new line character ASCII value is 10. Null character backslash 0. ASCII values 0. Okay. So these are the ASCII values which you can remember. Space it is 32. Single blank space. So capital A to Z 65 to 97. Lowercase a to Z 97 to 122. Sorry, 65 to 90. Capital A to capital Z, it is 65 to 90. Lowercase a to z, it is 97 to 122. Digits 0 to 9, it is 48 to 57. New line character, it is 10, the ASCII value. And for null character, backslash 0, ASCII value is 0. Okay, and don't get confused with this. If I print ASCII value of, let me just write ASCII value of 1, what will be the output? So this is one more point I wanted to tell. Don't get confused with integer 1 and character 1. I want to print this output. What will be the output? ASCII value of 1 is percentage %d, comma 1. If I execute this printf, what will be the output? I want to know the ASCII value of 1 and I have written this printf statement. If I execute, what will be the output? What is 1 here? What type of constant is 1 here? Can anyone identify the type of constant I have written in the variable list in printf?
An integer type.
Yeah, integer constant.
Integer type.
To print an integer constant, we are
ASCII
using
value of
format
1 is 1, ma'am.
1. Very good. It prints ASCII value of 1 is 1. But this is this the output we are expecting? I want ASCII value of character 1. So what is the change I need to make in this code? 1 should
Single
not be an
quote.
integer constant. Yeah, very good. We should represent this character within pair of single quote. Now compiler interprets this constant as a single character constant. So now it prints its associated ASCII value, which is 49. Just observe what is the output it has printed now. ASCII value of 1 is 49. So if I want to print this character 1, this is not improving the readability. ASCII value of integer 1 is 49, it is printing. So I want to just enclose this 1 within pair of single quote to interpret this as a single character constant. How to format my output? What change I need to make?
Backslash single quote.
Yeah. Before 1 you use backslash single quote. After 1 you use backslash single quote. Now you get the output. See? So in which format you want to have the output, accordingly you can do the formatting using this escape sequences. See? ASCII value of character 1 I have represented within pair of single quote is 49. So compared to previous output, this is more readable and it is more meaningful. Instead of simply printing ASCII value of 1 is 49, I have represented it as character 1 by enclosing that 1 within pair of single quote. Are you getting how we can make use of escape sequences in our output statement printer to write to print the output in required formats? Don't get confused with digits 0 to 9 with characters 0 to 9. Representing within single quote has a different meaning rather than writing directly that integer constant. Okay? If I simply write 49, so if I simply write this percentage %d, okay, comma 49, what it prints is, so since 49 is an integer data, 49 will be printed. But if I print using format specified %c, 49 is treated as an ASCII value, its associated character gets printed, that is 1. 1 gets printed onto the screen. Just see. Hope I'm not confusing you. Printf percentage %C, 49. 49 is treated as ASCII value. Format specifier percentage %C will print its equivalent character. Which character it has printed? It is character 1. It is not integer 1 that is printed on the screen. It is character 1. If you want to make it more meaningful, you can enclose it within pair of single quote. So before percentage %C and after percentage %C, you can use pair of single quote. Are you getting? Given with some set of constants, you should be in a position to tell what type of constant it is. If you're having a whole number, you have to tell it is an integer constant. If you're having a decimal point in that number, you can tell that it is a real constant. If any character, single character enclosed within pair of single quote, you have to tell that as a single character constant. If whether it is a single character or sequence of characters enclosed within pair of double quote, you have to tell that constant as a string constant. So this is how constants are classified. So this is how you should be in a position to identify what type of constant it is. So all those exercises you can do in tutorials. Give the material so that you can solve it. Have you followed whatever we discussed in today's session? Okay.
Yes, ma'am.
Okay.